Hi, this is Lori, and this is my homework for Paul McWhorter's Pico W course. We're on lesson 53. We're continuing to work with our NeoPixel strips, and now we're going to work a little bit with looping through the color wheel. Now, before we do any of the programs, I just thought I'd point out my setup is pretty much the same as it was for the last homework. The only thing I've changed here is I have added a 5x5 matrix that I'll do a couple programs with. I just got that in from AliExpress, and I'm really looking forward to doing some stuff with it. And then since I do have a 5x5, so 25 NeoPixels on there, I decided to give some power to the breadboard. So I have just a power module here, and I'm putting some power on this rail so that we get 5 volts to run the 5x5, and I have the NeoPixel strip plugged into it too. So that's where the power is coming from in the layout now. First program will be working with the string of NeoPixels that we have in our kit and looping through the color wheel. So this is really just putting together a couple of our previous homeworks where we worked on taking the color wheel and turning it into RGB codes. So I'm still going to use my potentiometer that I set up in the last experiment to control the speed that we're going through the color wheel. And I have a color dictionary here, but I only need the black color. But since I've already typed it in, I just copy and paste it from previous programs. And then I kind of cleaned up my, in the previous homework several times ago when we did that color wheel stuff, I did have a hue, saturation, and value to RGB function. So I just stripped out the saturation and value parts of it since we don't need that for this homework, and it makes the code a little cleaner. So this code, kind of works the way that Paul showed us how to do, and I know Keith pointed out a different approach where we make sure we only have one of the LEDs kind of full on at any one time to kind of keep the brightness the same using sort of the Adafruit color wheel approach. I haven't really dug into that too much yet, so this is still the way that kind of Paul taught us and just cleaned up a little bit. I did create a couple of helper programs. I wanted a program to control the brightness because you really don't want these LEDs full brightness, so I just have a little function called brightness here where you give it the RGB code in the kind of the full brightness, and then whatever level. So you can kind of think of this as something from 0 to 1, 1 being it wouldn't change the color codes, and in this case, like the default is 20% of the color code that you input here. And so I did use a little list comprehension here to multiply each of the codes by the level and return it as a tuple. And then I made a little clear function just to avoid continuing to write these two statements all the time. A couple of the other programs I clear the screen quite a bit, so I thought it was nice to have. And then here we're just going to loop through the color wheel, use the potentiometer to set the speed, the delay time, and we'll go ahead and fill the whole string with the color, the various colors as we go at 1/10 of the normal brightness, and sleep the delay time and keep looping around until we hit keyboard interrupt and clear the screen out and turn everything off. Well, the first time I tried to record this, it was just too bright, so I've turned all the lights off so maybe we can see the NeoPixel string just a little bit better. So I'm doing another take on this to see if it works. All right, so let's go ahead and run it, and hopefully we'll see the colors a little bit better. I'm checking it out here in the monitor, and I have it going pretty slowly through the color wheel. It's a little bit better. It's still kind of hard to see, isn't it? All right, so let's speed it up a little bit. And we'll speed it up a fair amount. Let's try to get it going pretty quickly through the color wheel. And you can see some of it. There's the pink and a loop through the red. And just a challenge to get it all to be seen. But take my word for it, in person it really is going through the color wheel. All right, I think this is as good as it's going to get. I probably need some kind of diffuser or something for the strip to film it a little bit better than this, but that's what I've got. So I just thought I'd show how I put the little 5x5 NeoPixel matrix together. This is what it looks like, and here's the numbers of the pixels for coding. And so you can see it's kind of like a little string of them here. And this, the way I soldered on some headers to it is makes this bottom corner 0, and it goes from there. So that way you can kind of get a little bit of a sense of how I lit certain pixels. All right, so let's go look at the programs. The idea here is to use our color wheel function and think of the square, I guess that's a square, as a circle, and put the color wheel in kind of the approximately right space on the square, as though it were a circle, and then kind of move it in and out. So probably the easiest way to figure out what I'm talking about is just for me to show you. So let's demo it first. So okay, go ahead and run it, and the potentiometer is involved here so we can make it go faster. So the idea here is, again, we're putting the color wheel all around the circles. And so there's a 16 on the outer square and 8 in the inner, and so I'm just trying to give them the spot that they would be if that square was a circle, I guess, and put the color wheel out there. So we can use the potentiometer to make it go a lot faster if we want, because, you know, just going faster is fun. So yeah, so that was the idea, and it looks a lot better in person than it does filming it, but that's just the way it is with these pixels. So we'll go ahead and stop it, and now we'll talk a little bit about the code. So the setup of the code's all the same as I've done before, so I'll skip past that. Next, we just need to define the a list for all the pixel numbers that are in the outer and inner square, and then the middle pixel. And in the while true loop, we'll read the potentiometer to set the delay time. We'll clear out the matrix, turn on the middle pixel, which I just made white, and then sleep the delay time, clear it out. Then we're going to turn on the inner square. We'll move through the circle by using a hue value, and then each time we go through the for loop, we'll add another 45 degrees to set the next pixel. Write that all, sleep, clear it out. Then we'll turn on the outer square, and we'll do a similar thing, and this time we'll just add on 23 degrees because we start over again, and write that, sleep, and then we just need to put another inner in to go backwards, so to speak, and then we'll loop back around and turn the middle pixel back on again. So that's, you know, looks like a lot of code, but it really isn't. And then a keyboard interrupt cleaned it up. So that's how I made that animation, and that was a lot of fun. Well, for my last one, I decided to just mess around with the 5x5 matrix and put some letters on it, and just you know, the idea of the square made me think of this. Oh, I could make lists of my letters of my name, and so I spelled out Lori and figured out what the pixels were to make Lori. And this time we're just setting a specific delay time. And then we'll go ahead and put each of those letters on the screen, and we'll sleep. Put the letter on the screen, and we'll sleep, so forth, and go round and round and round. I guess next step would be to have it scroll off, but I need to do something else today besides just play with this matrix, so I need to stop here. But this is the last thing that I did. All right, so let's run it and see my name and lights. There we go. Yeah, that's fun. And you put your name in whatever colors you like, and eventually you could build up the whole alphabet and probably find a much more efficient way to do it. I hope Keith will tell me there's a special way we should do this. Plus, it's kind of fun to put messages out there with your NeoPixels. Okay, so that's my homework. Thanks for the great lessons, Paul, and thank you for watching.